In this video, I am going to solve this second order homogeneous differential equation. It has constant coefficients and the equation is 25y double prime minus 40y prime plus 16y is equal to 0 with initial condition y of 0 is equal to 10 and y prime of 0 is equal to 12. This is a situation where the roots are repeated, as you will see shortly. So let's call our fresh solution is of the form y1 of t is equal to e to the power rt, and then if we take the first and second derivative we get y1 prime is equal to r e to the power rt, and then y1 double prime is going to be r squared times e to the power rt. Now if I take these values and plug it into this equation, I get the following: 25 r squared minus 40 r plus 16 times e to the power r times t is equal to 0. Here I just did a little bit of algebra without writing it. I just plugged in these values, and factored out e to the power rt. Now obviously e to the power rt is not going to be equal to 0, right? You have a product of two factors that leads to 0, and e to the power rt is an exponential function and it is not going to be 0. Hence the other one has to be equal to 0. So that gives me 25 r squared minus 40 r plus 16 is equal to 0. Now I need to factor it. So 25 r squared minus 40 r, I need to break it down into two pieces. So what do? As it turns out, I could just write it as 20r minus 20r. That should do it, I think. Because negative 40r is negative 20r minus 20r, then plus 16 is equal to 0. Then I could factor out 5r from here. That's going to give me 5r minus 4. I could factor out negative 4 here. That's going to give me 5r minus 4, and that is equal to 0. So 5r minus 4 times 5r minus 4 is equal to 0. So if I solve for r, is going to be 5r minus 4 is equal to 0. That implies that r is equal to 4 over 5. And we have this root repeated, right? R is equal to 4 over 5. So what is my y1 of t? My y1 of t is going to be e to the power 4 over 5 times t. Now, as we know, for repeated roots, the solution is going to be of this format. Y of t is equal to c1 y1 of t plus c2 times t times y1 of t. And I'll just plug in these values. Okay, so y of t is going to be c1 times e to the power 4 over 5t plus c2 times t times e to the power 4 over 5 times t. Now let's go ahead and use the initial conditions. So initial condition y of 0 is equal to 10. So if I plug it into this one, this one, I'm gonna get 10 is equal to c1. Why is that the case? Look, this is gonna be, t is gonna be 0, so e to the power 0 is 1, and there is a t here, so that's gonna vanish that term because t is 0. Now to use the second initial condition, I just need to take the derivative of y. So y prime of t is gonna be 4 over 5 times c1 times e to the power 4 over 5 times t. Now to take the derivative of this, we need to use the product rule. So it's going to be plus c2 times e to the power 4 over 5 times t, then plus 4 over 5 times c2 times t times e to the power 4 over 5 t. Now y prime of 0 is equal to 12, so it's going to be 12 is equal to 4 over 5 times c1, and t is 0, so it's going to give me e to the power 0, 1, plus, again the same thing here, e to the power whatever is going to be equal to 1, in this case 0, right? So c2. Now I just need to solve for c2. So c2 is equal to 12 minus 4 over 5 times c1, or c2 is equal to 12 minus 4 over 5. 4 over 5 times c1. What is my c1? 10. So that's going to be 12 minus 5 goes into 10 twice, right? 2 times 4 is 8. So that's going to give me 8, right? 4 times 2 is 8. So that's going to give me c2 is equal to 4. So my c2 is equal to 4 and my c1 is equal to 10. Now if I plug in these values into the equation, I get y of t, which should be my final solution, c1, which is 10 times e to the power 4 over 5 times t, plus c2, which is 4 times t times e to the power 4 over 5 times t. And this, by the way, should be your solution to this differential equation with the given initial conditions. I hope that this discussion was helpful. Thank you very much.